Hello, my name is Usama Al-Ayati. I am a PhD student in FST, Central University and Research and Development Engineer at Innovation Lab for Operation, Mohammed VI Polytechnic University in Hungary. Today we will talk about the smart energy management systems and specifically the energy consumption, metering, monitoring, and prediction for mining industry approach. This overview is or represents the methodology of this work. We will talk about energy consumption, introducing a specific energy consumption problematics in the mining industry, the energy management system according to ISO 50001, introducing machine learning and study the impacts of artificial intelligence and its impacts on energy management systems to making it smart, and gives a comparative study between models and in different applications, and it proposes an innovative architecture for a smart energy management system in the mining industry. So, the main problematic is implementing a smart energy management systems for mining industry by upgrading and improving the energy efficiency. These solutions, according to ISO 50001 standards, can reduce the carbon growth in only industries, and building can save a $3.2 trillion for public health without implementing machine learning and optimization algorithm solutions nor digitizing these operations. So, we will study the impacts of energy consumption on energy management systems according to this ISO, applying the functionalities of Industry 4.0 to digitize industry, integrating SCADA, smart meters, and smart storage and data storage, introducing machine learning for prediction, forecasting, and making energy management systems smart, applying the approach on mining industry and integrating its KPIs, maximizing production and minimizing energy costs, energy loss, and grid failure. As we said before, this approach will help to save $3.2 trillion American dollars just for public health without introducing the machine learning and optimization algorithms to improve this saving. 27% of implementing an energy management system case studies have an insufficient or a lack of energy consumption data and other requirements. The abnormal energy consumption behavior of different machinery in the mining industry. Energy loss, energy costs are not well managed in the mining industry. Digitizing energy management systems and making it smart while enhancing the ISO 50001 standards. To implement the energy management system, we propose an automated energy performance reporting system using the PDCA approach, plan, do, check, act, to increase the profitability from energy, digitizing energy efficiency, and improving the fluidity of information, specific KPIs for a better monitoring and controlling the energy loss, scheduling dispatchable distributed generations, and control multiple loads and end users for managing energy consumption in the mining industry microgrid. For the plan, we have the awareness creation, plans benchmarking, do phase. We will have opportunity identification, risk and projects implementation. Check, we have the KPIs, monitoring, reporting system, and act, we have a basic idea on budgeting and gives and additional ISO tasks. This will help us for a continuous improvement. Introducing machine learning. The machine learning it is a good tool to make the energy management system smart by predict and analyze and diagnose energy consumption abnormal behavior for a better energy management system, proposing a predictive model for energy consumption in electric power grid using data from feeders and from machines for specific KPIs, and proposing neural fuzzy inference, time series, and support vector, encoding them into Markov transition factor to detect anomalies and predict energy consumption. This scheme or architecture shows the data processing, feature extraction, time series imaging, and a well-trained model to classify the defects or the abnormal activities using support vector machine, and the other one to predicts the energy consumption and to shows the abnormal activities. So for this part of the paper, we will talk about or we will present a comparative study between models based on the results of a well-defined and well-developed by Kadir, comparing between different applications of smart grid management and adding other recent works, of course. Here listed a comparative table of many teams worked on applying machine learning algorithms to predict the energy consumption in various applications. Here we sort this this comparative study by year. Here we can see different teams in different countries working on non-residential building, residential building, multiple building, large commercial building, non-residential building, etc., shopping center, etc., using different algorithms such as neural network, support vector machine, Bayesian network, etc., and some linear regression and non-linear one. And we can see here some very satisfying accuracy. From this comparative study and recent works in energy consumption prediction, it is known that all these methods are applied for residential building, university, hotels, offices, large commercial buildings, hospitals, etc. And one application in the industry of mechanical manufacturing presented by Wei, who proposed a study for forecasting the energy benchmark using phototopsis algorithm. The results were very satisfying, but it still can be enhanced by other applications in the state of art, such as detecting abnormal behavior, introducing optimization algorithms, and correlated with the energy cost with the production profits which can be produced in the future work based on or applied for the mining industry. This is a basic architecture for data collection. We will use a voltage converter and current converter. This is basically a current and voltage sensor with the counting display interface to PLC, etc. This is a smart meter, and here the data preparation procedure, modeling, evaluation, preparation, deployment, etc. We will have the current and voltage have the basic data collected from the machines by the smart meter, read by the PLC, the programmable logic control, and store these data into an energy database and visualize the real-time data into Scala and we have the algorithms. The algorithms results shows into the SCADA, and show the results in the SCADA system. Here is an architecture for the smart energy management for system for mine industry. Here is the machine. Here are the machines that we will work in the future work. Of course, we have reclaimers, drag lines, different type of scheme, square cage induction motors, lighting, etc. For the control, we have some PLCs, servers, and dashboards, and we will integrate other energy sources to make it a microgrid, and using artificial intelligence. This is we can collect the energy data acquisition here from all these energy sources and loads. We'll go the data preparation, storing the data in the database. After, we can visualize everything, the real-time data, and the results of energy management algorithms that will help to diagnose the defects and abnormal activities, and predict the energy consumption that can help the management system to energy planning, purchasing, energy controlling, etc. This paper is a current state of art of energy management systems in different applications, and machine learning algorithms applied in these applications, and gives a comparative table between all these applications. It is known that integrating smart intelligence algorithms based on machine learning, diagnosis, and predicting models, etc. The comparative study shows that using fuzzy top-6 algorithm gave very satisfying results for prediction, forecasting, energy benchmark per stage in a production line. The neuro fuzzy inference time series forecasting shows very good results for energy consumption prediction. The classification algorithms, port vector machine, and the nearest neighbor are very good to detect abnormal energy behavior in mining machinery. The general idea introducing SCADA systems, sensors, data preparations, and decisions algorithms. The proposed architecture shows the smart energy management system to be implemented and integrated in the production KPIs for mining industry. For the future work, based on the proposed architecture, sensors, storage, data preparation, processing, KPIs, and decisions, and algorithms benchmark, the next steps are deploying a real-time platform for smart energy management system for mining industry, developing different algorithms to predict specific energy consumption per machine, preparing database and describe the behavior of different mining machines, such as reclaimer, drag lines, etc. Detecting abnormal energy behaviors of machine correlated with production KPIs, test and validation of the system and algorithms in the real-time platform. The same application is targeting a campus with renewable energy sources and developed a smart control system and requirements to implement according to ISO 50001 and enhance the standards by introducing digitization into in the revolutionary concept of Energy 4.0. Here are some references. And thank you for your attention.